I'll get started by talking a bit about our title. So we are going to be talking about characterizing bias, and this is in fact a pun on Chinese characters because we are going to be talking about Chinese in the context of LLM biases. And in particular, we're going to be thinking about simplified Chinese character versus traditional Chinese characters, where simplified Chinese predominantly used in mainland China, whereas traditional Chinese more predominantly used in Taiwan, Hong Kong, Macau. There's a lot of overlap in these written scripts of Chinese, so a lot of characters are the same, but of course some specific characters are different. Some of them are just a one-to-one mapping of a character difference, though they're pronounced the same, and some of them are pronounced entirely different. They're entirely different words. So there was an export issue. There should be a picture of a pineapple here, so pretend like there's a pineapple. If you were talking about a pineapple, if you're in Taiwan, you would call this a fengli. If you're in mainland China, you would call this boluo, right? So two totally separate words for the same fruit. And it turns out that if you ask LLMs prompted in different variants of Chinese, you might get some different answers. So this is a definition of a pineapple asked to different LLMs in simplified Chinese, and it turns out that GPT-4o gets this right. Tianwen, which is a simplified Chinese LLM, gets this right as well, but Taiwan LLM, predominantly trained in the Taiwan context in traditional Chinese, gets this slightly incorrect. So it does get the word pineapple, but it uses the traditional Chinese term for pineapple as opposed to the simplified Chinese term, which we might want or expect, given that the original prompt was in simplified Chinese. Now let's say we ask the exact same question, but now in traditional Chinese. So this is all in traditional. GPT still gets this right. Tianwen now thinks that this is a papaya, and Taiwan LLM thinks that this is a lychee. Right? So huge issues with how we might expect LLMs to respond to different types of Chinese. And so this is clearly a problem in the general knowledge generation space, but there's one other big modality that we're worried about, which is AI used in hiring. So this is a space that a lot of folks have worked with in the English language context, right? So thinking about resume audits and these sorts of studies. So what about in the Chinese context? So it turns out that last names and first names might also be quite different. So if you just take the common last name Chen in Taiwan, this is the most popular surname, and it's written, it's still pronounced Chen, but it's written in a certain way. It's written differently, but still pronounced Chen in simplified Chinese, and it's significantly less popular in mainland China. You might think about another example of Lin, which is written the same way in both simplified and traditional characters, but also can lead to LLMs maybe intuiting the provenance of a name. And so we are quite worried about the potential biases that might arise from just looking at these different names. So what we did in this paper are three primary things. So firstly, we created a benchmark data set. So this is available on GitHub with this QR code. And the two tasks that we study are firstly about regional terms and biases that might arise, so from things like pineapple. And the second thing that we study are regional names, so the different types of names that might exist cross-strait between Taiwan and mainland China. We then evaluated performance on 11 different LLMs, covering LLMs that are English-oriented, so things like GPT, predominantly trained in the English language, as well as simplified Chinese-oriented and traditional Chinese-oriented models. And lastly, what we do is we actually quantify the biases that arise from these different tasks and think a bit about what might be driving these biases that we find. So first task, regional term choice. So very similar to what we did with our pineapple example. We grab 110 different terms that are specifically written differently in simplified versus traditional Chinese. We get their definitions, and we ask the different LLMs to define what these terms are. And ideally, if an LLM is asked something in simplified Chinese, they respond in simplified. If they're asked in traditional, they respond in traditional. And so what we find, each of our x-axes is each of our LLMs that we audit. Looking just at Tianwen first, we can see that the correct responses are nearly 60%. Of course, 40% are then incorrect. But this is all when you're prompting in simplified Chinese. So you can see there's a little S, so this is the left words bar. But if we prompt all of the same questions in traditional Chinese instead, we now have this big yellow bar. And this yellow bar represents misaligned terms. So essentially what's happening is you're prompting them in traditional Chinese, and they're responding technically correctly, but in simplified Chinese instead of traditional Chinese. So they're getting the wrong term, but the right understanding of the term. And we see that this pattern holds across all of the LLMs that we audit. So consistently, we see more of these misaligned terms when you're prompting in traditional Chinese as opposed to simplified Chinese. So why does this happen? We'll defer most of this explanation to the paper. The short version is that there's a massive underrepresentation of these niche traditional Chinese terms that are often underrepresented in likely the underlying corpora. So second task that we're going to work on is on name choice. And essentially what we do here is we grab a corpus of about 400 of the most popular names in mainland China and Taiwan, and we ask the LLM, given a random set of 20 of this batch of names, and we re-roll the dice on names many, many times. Here's a set of 20 names. Choose one of these names to hire, assuming that all of these candidates have comparable abilities. And so ideally, either our model should not respond because it should know that we shouldn't be choosing people to hire based on just their names, or if it does respond, hopefully at least there's some sort of balance. We can argue about what specific fairness metric we want to use, but maybe we want to balance on the share of mainland Chinese names being comparable to the share of Taiwanese names. So what we actually end up seeing is a flipped result here. So for names, there does seem to be some bias towards traditional Chinese names. So each of the dots on this figure represents one of the LLMs that we audited. We're just going to look at the y-axis for now. So there's only one LLM that we looked at that among all of the times that we polled these LLMs, that specific LLM ended up choosing more mainland Chinese names relative to Taiwanese names. In contrast, the vast majority of LLMs had a far higher propensity to choose a Taiwanese name. Across the x-axis, we're looking at adherence to prompt instructions. So you can see, for example, Taiwan LLM almost never actually adheres to the prompt and rejects the notion of choosing a person. Whereas we end up seeing that, for example, GPT-4o and DeepSeek always actually adhere to the prompt instruction and give you a name. And this pattern holds true regardless of the prompting language. So you can prompt in simplified Chinese and traditional Chinese and English, and you always end up with this kind of general tendency towards traditional Chinese names. So why does this happen? Does anyone in the room happen to recognize any of these celebrities? Okay, great. I see one person nodding. So both of these celebrities, one of them is a stand-up comedian and one of them is like a boy band idol. So effectively, they both have very common names. And so both of their names actually are in our corpus of the top 400 most common names that we have. And so maybe it's just that we have some really popular names in our corpus, and those are the ones that are being chosen. Maybe that drives our findings. So we ended up doing a bunch of process of elimination tests to see if this ends up being the case. So the first question is name popularity. So maybe if names are overrepresented in online corpora, so like celebrity names, maybe that's the issue. So what we do is we balance our selection of our 20 names, so 10 simplified Chinese names, 10 traditional names. We balance them by decile of Baidu search popularity. So even if we balance on that, we still see the same effect. Next we say, okay, what about name population popularity? So let's say that these names are super common versus not common in the actual population. Does that matter? We do the same decile balancing. Still doesn't matter. We still have a general tendency towards traditional Chinese names. We think about gender. It turns out that there is a pretty big gender bias for male names. So LLMs are across the board more likely to select male names. But even if we balance on gender among the names that we propose to the LLMs, this still gives us some traditional Chinese bias. So what we end up seeing is that, firstly, there does seem to be some preference for specific characters. So characters that are like Jian, which means handsome, or names that invoke talent in the LLM's point of view seems to overperform. And the other big thing that drives the results is a specific preference for names written in a specific script. And what this means is we specifically subset to 3 names that are written differently in simplified versus traditional that all happen to be in our top 400 corpus of popular names. And if you subset to this set of 6 names, so 3 in simplified and 3 in traditional, the LLMs will almost universally totally flip directions and all choose the simplified names. So in this case, it seems like the written script actually matters a lot. We think this has to do with tokenization because tokenization ends up leading to fewer tokens when you have a name in simplified Chinese as opposed to traditional. So with that, some calls to action. Please use our benchmark if you're thinking about what LLMs to use for your work going forward. And for developers, I think there's a lot more work to do in terms of thinking about diversifying your underlying training data, especially for more niche variants of languages, and also, of course, mitigating potential biases arising from tokenization. All right, thanks so much, everyone. Questions?